Greetings, class. This is the first of what might be a small handful of segments on probability. Probability is an extremely important subject to understand in inferential statistics because it is through the study and understanding of probabilities where we are able to determine whether or not the things that we observe in research are unusual or rare versus something that might occur simply by chance alone. And I don't know if it's too early to really introduce that yet, but that's really, in a nutshell, that's really what inferential statistics is all about. It's all about making the decision about whether or not what we observe mathematically could reasonably have occurred simply by chance, simply by accident, or if there's something else going on at work. So I don't want to get too far ahead of myself, so I thought maybe I would begin by highlighting something that Spatz presents to you in Chapter 6, and that is the rectangular distribution. All right, the rectangular distribution. And if you recall, Spatz used this drawing, or his version of this drawing, this is my version, he used this concept, this drawing, to illustrate the likelihood of specific outcomes. All right, so for example, in an honest deck of cards, you have, in terms of the type of card that you draw, you have 13 options essentially: ace, 2, 3, through king. Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. We're not worrying about color of card, red versus black, and we're not worried about suit. So in an honest deck of cards, there are 52 cards, and there are 13 different types of cards, and there are 4 of each type. So there are 4 aces, there are 4 twos, there are 4 threes, there are 4 fours, there are 4 jacks, there are 4 queens, and there are 4 kings and 4 aces, etc. So this is an example of a rectangular distribution. A couple of things I want to point out, although Spatz pointed them out as well. The top of the distribution, even though in this particular case it's actually a straight line, the top of this probability distribution is referred to as a curve. Even though it looks straight, it's referred to as a curve. And the area underneath the curve is 1 or 100%. Now, if you go ahead and, let's see, the name, I should have started with this, I suppose. The name of this handout is called Rectangular Probability Distribution Drawn. So it's a drawing of the rectangular probability distribution. If you want, or if you haven't already, go ahead and pause the video and find this or get it and print it. But if you have it, you'll notice, or if you don't have it, you want to just look at your screen, I have repeated the probabilities of each event occurring based on a random draw from the deck. So because there are, for example, starting down here with aces, because there are 4 aces in the deck, and there are 52 cards total, 4 divided by 52 is 0.077. That is the probability of drawing an ace expressed as a proportion, 0.077. And expressing probabilities as a proportion is perfectly legitimate. However, you can also express probabilities as a percentage if you like. For many people, it's a little bit easier to think about percentages because we're used to thinking about numbers between 0 and 100. The concept of percent per 100 sometimes is something that we're brought up learning about and around and use. You know, the percent of the percentage chance of rain is 60%, right? So we conceptualize that, we can understand that. And so you can express probabilities as a percent as well. So I converted each of those proportions, 0.077, to their corresponding percentage simply by moving the decimal point 2 places to the right. So a probability of 0.077 expressed as a proportion becomes a percentage of 7.7%. And again, as you can see, since there are 4 cards of each type in the deck, the probabilities are all the same. So the probabilities of drawing a 4 are the same as the probability of drawing a 5, which is the same as drawing the same probability of drawing a 6, and so on. Probability is also additive, right? So if you wanted to, if I asked you using this probability distribution, what are the chances of drawing a 9 or a 10? A 9 or a 10. So if we view that particular outcome, drawing a 9 or a 10, as a success, what are the odds of success? What are the odds of drawing a 9 or a 10? Well, all we would have to do is add 0.077 plus 0.077, and that would give us our answer. Likewise, what's the probability of drawing a face card, meaning a jack, queen, or king? I'm not much of a card player, so I can't remember if an ace is considered a face card. I'm going to guess no, because there's no face on it. Whereas with a jack, queen, or king, there's actually somebody's image of a face or a drawing of a face. Well, we can calculate those probabilities as well. What's the probability of drawing a face card? Well, we would simply add the probability of drawing a jack to the probability of drawing a queen to the probability of drawing a king. 0.077 plus 0.077 plus 0.077 would give us the probability of drawing a face card given one random selection from the deck. If we wanted to convert that proportion to a percentage, we would simply take that number and move the percentage 2 places to the right.